Oh, I can't believe I have to do this stuff. I'm getting sick of this hobby. Turn the air conditioner off. I'm getting sick of this hobby really quick. All right, I took chemistry 101 at Wichita State University. I think I got a B. This is my periodic table. I think I know a little bit about chemistry. I think I know a little bit about non-metal uses, negative towards noble gas config, MDNO, DI, tri, tetra, penta. Okay, those are all stuff that we made at Vulcan Chemical. A tetra is pretty. It's not as mean as hydrofluoric. Well, maybe it is. I don't know. Questionable. Hydrofluoric just kill you, you know. Tetra, it probably kill you too. And I spend a lot of time in the tetra plant. But anyway, do I know anything about chemistry? You ever see a periodical table with this kind of stuff written on it? Have you got one yourself? What'd you get in chemistry? Seriously, that is my periodic table. Yes, I have studied a little bit of chemistry in my time. And I have worked. Just back it up. Back it up. Set you on the couch here. Hope you can see it. Okay. Hope you can see it. Oh, and by the way, this is fingernail polisher. And what fingernail polisher is acetone that has been pH buffered so that it will not harm things. pH buffered means that it has had an alkaline added to it to neutralize the acid in the fingernail polish. Not in the fingernail polish, in the acetone. That's how bad the acid is. Okay? I'm not saying it's real bad. Actually, I'll tell you how bad it is. A 5.5 pH is about like fertilizer, like you would put in your garden. You put that fertilizer in your garden, you don't put it on your coin. Okay? Go ahead, put it on your coin. Now I know why all the coin collectors' coins are toned, and it's all artificial toning. They put acetate on there, or acetate. They put acetone on there. I don't know if they're using acetone or acetate. No, it's acetone. They put it on the coin, and then the solvents evaporate. They go away. Solvents have no minerals. Water has minerals in it. Okay, so when water evaporates, goes away, it leaves minerals on the surface. Okay? Oh, man. Okay. A liquid such as dry cleaning fluid, I'm not going to say dry cleaning fluid because dry cleaning fluid is pH balanced, but you could put an acid into a dry cleaning fluid and it would evaporate away, but it's not going to leave any residues, okay, because it just evaporates away. But what doesn't evaporate is the pH, is the salt. Okay, the salt. I'll go into salt here in a minute. That salt does not evaporate. It's not considered a residue because it's a crystal. It's a salt crystal. It's a alkaline and an acid mixed together, which makes a salt. If there's more acid, then it'll be an acidic salt. If there's less acid, then it'll be an alkaline salt. But it's not considered as a residue. And yes, it's still sitting there on your coin. And when moisture from the air, humidity, comes in contact with that, then it will begin to erode away the silver and turn it into a silver oxide crystal, which cannot be evaporated. You cannot evaporate salt. Salt does not just poof, disappear. So why are they telling you that it leaves no residue? Well, it leaves a thin coating of salt. That's not a residue. You're not going to wipe your finger across there and look at it and, oh, I've got that residue on my finger. Okay, salt's not coming off. And toning is salt. So I worked at this chemical plant called Vulcan Chemical in Wichita. I was a draftsman. For the first year, I drew P&IDs. For the second year, the other people just get, here, draw this. Make it look like this. The next year, I began to go out in the plant and do my own P&IDs. So I didn't have to have some plant operator go out there and draw a picture of it. I just went out there and drew a picture of it myself. Okay? And then in my third and my fourth year at Vulcan Chemicals, I did civil design and piping design. Mostly metal buildings and steel structures and a whole lot of pipes and pumps and tanks and reactors and distillation columns, and I designed all kinds of stuff. So I know a little bit about it. I know a little bit about what people in chemical plants, people who make chemicals, think about this. I had to go to the safety meetings. I was not allowed to go out in the plant without having attended safety meetings to know about this stuff. So, and by the time I was done, I was looking over P&IDs, piping and instrument diagrams, and telling the engineers, hey, you got a problem here. See this check valve? That's not going to work. You can't do that. You're going to shut down. Where's my pointer? Air products. With that, but just because that check valve, you're going to shut down. When you shut down here, you're going to shut down all of air products hydrogen. Oh, got to fix that. So, you know, I'm fairly familiar with this. So this is Vulcan Chemicals in Wichita, Kansas. Now let me tell you what Vulcan did. Before, way out over here, way out over back in here, there's some wells. They're called injection wells. What we do, we drill a hole in the ground, we throw a piece of dynamite down there, and it cracks up the salt, and then we drill wells all the way around it, and then we force water down the middle well, and salt water comes out of the surrounding wells, and then we pipe that salt water over to right there. Let me zoom in on this. Okay, to this big tank right here, and we fill this tank up with salt water. And then that salt water goes into this cell room and this cell room. 24,000 volts coming right in here into this rectifier. I have a special pair of boots that I have to wear when I'm working on that rectifier. And both of these buildings had to design shields, explosion shields, for the rectifiers. We installed explosion fields. You go in this office right here, the guy sitting at this desk has paper clips stuck all over his desk because these things are so 24,000 volts of electricity is going here, and these things are so magnetic that your keys, like if you held this up and you went like this, it would try and turn, or you went like this, or you went, these cells are constantly acting on metal objects that are in your pocket. That's how bad the waves are in this area. It's just, some people say it's dangerous, and maybe it is, I don't know. But anyway, the salt water goes in here, 24,000 volts of electricity comes in here, and it breaks this salt water into chlorine and hydrogen gas, and then a solid caustic soda comes off the bottom. We heat it up to make it molten, and we ship it through molten lines, 450 degree pipes over here, and we make caustic soda beads out of it over here in the caustic soda plant. So what the gases that come off are hydrogen and chlorine. We take the hydrogen and the chlorine and we go over here to this area and we burn those back together. We mix them together, light them on fire, and then we catch the gas coming off of it, and that's hydrogen chloride gas. I have a story about that. I was standing right here when the hydrogen chloride from this sodium chloride plant sent 7 people to the hospital, and drifted this way, and by the time I was right here, my eyes and my lungs were burning, and I barely made it in that door right there in that building and said, what the heck was that? 7 construction workers from Brown and Root went to the hospital from that gas release. So it doesn't have to leave a residue, okay? It just has to leave those salt crystals. That's all. So, DubC, you're just wrong about this. You know, what you're looking at here, you're thinking that you're dealing with this right here. This is perchloroethylene. This is where we mix propane with chlorine together to make a solvent, perchloroethylene, that's called dry cleaning fluid. And the reason they use dry cleaning fluid is it leaves no residues. All right, it fully evaporates. But if there's salt in it, salt does not evaporate. The only way that you're going to get the salt to break down is to go back over here and run 24,000 volts through it and break it back down into caustic soda, hydrochloric acid, and chlorine. This is a chlorine plant, mostly. I mean, this is a chlorine plant here, pentaclant plant here, perchloroethylene here, chlormethane's one here, and chlormethane's two here. Okay? So what you're thinking about is dry cleaning fluid, But dry cleaning fluid is pH balanced, just like the fingernail polish is pH balanced. But it's not pH balanced with a salt. So it all evaporates. Doesn't leave in the salt, dry clean, perchloroethylene doesn't leave anything on the clothes when you clean them. But that's not what acetone is not perchloroethylene. Okay? It leaves salt on the surface of the coin, and that salt's pH is at that liquid level, at your original in the can, is 5.5. That's acid. That's a mild acid. Here, let me show you. See right here, it says no acetone is generally safe to use on metal and is often used as a solvent to clean it. Acetone is a common solvent used for cleaning metal surfaces, removing dirt, grease, stains, often used in industrial settings for machinery, 3D printers, so on and so forth. Acetone dries quickly, which can be useful when cleaning metal before painting. That's because it's a solvent. Solvents. This is also a solvent. This is gun bore cleaner, and it leaves oil as a residue, but it doesn't leave any salt. It's pH balanced, so it doesn't hurt your gun, the steel. Acid harms any kind of metal. That's what you learn in chemistry. I should have showed you the back. It's more notes drawn by Dressen. On standing, acetone can form peroxides which may then explode. All right, it's saying, no, it doesn't leave a residue, it leaves peroxides. Okay? Peroxides. It doesn't leave a residue, it leaves peroxide. Acetone will react with iron and steel in the presence of moisture. When the moisture hits the salt, the toning starts, the damage starts, the silver starts being eaten away. You guys just piss me off. I'm getting sick of this community. They don't know what they're doing. It's crazy. Yeah. I know why now coin collectors are all have a bunch of tone coins. And according to me, it's artificial because they're the one that put the acid on the coin and let it sit there in the first place. Although I've never seen anybody sit there. Everybody says rinse it off. Everybody says rinse it off. With if you use distilled water, you're going to have a pH 7. Okay, and that will help to neutralize the pH 5.5 acid. You're better off to use dish soap because it is a pH 8, which will neutralize the 5.5 almost up to 7. Okay, and at 7, you are at the pH of distilled water. That's your breaking line. Distilled water is 7. Okay, acidic water is under 7, and alkaline water is over 7. Okay, 7's the breaking point. That's why you use the distilled water. But you should go even past that. Go to 8. Because the alkalines at 8 will not react with the metal like your salt reacts with the metal at 5.5 when it is exposed to humidity, which is moisture. which causes the decay of your coin, which turns pretty colors of blue and green and orange, and you just love it, even though it's just destroying your coins. That, my friend, is the bottom line. All right, that's the bottom line.